Assalamualaikum warahmatullahi wabarakatuh. I'm the representative of Putri, and I will talk about the algae batch culture of Tetrasalis sp. So the introduction here, microalgae are microscopic algae that live in the water column and sediment. It also can be found in perforated and marine water. So in this experiment, we use the Tetrasalis sp, which is a unicellular organism with 4 flagella in 2 opposite pairs. So this Tetrasalis sp is under phylum Chlorophyta and class Prasilophytes. Culture algae consists of 3 components, which is culture medium, and we use F2 and water medium in this experiment. Algal cells, and we use Tetrasalis sp, and air is to allow the gas exchange happen. Okay, so there are 5 group phase of microalgae, which is the first one, as you can see here, is a lac or induction phase. The second phase is exponential phase. The third one is phase of declining relative curve. The fourth is stationary phase, and the fifth is the dead phase. When this is basically we already harvest our culture algae. So the objective of this experiment is to do a small-scale batch culture of the same microalgae in different culture media. We use F2 and water medium, and we use the same microalgae, which is Tetrasalis sp. The second one is to compare the growth phase of microalgae by observing its morphology, size, color, and density from start until harvest. Then the last one is to compare algae growth rate, division time, and yield as fresh weight and dry weight per unit volume.
So for the methodology for batch culture, first we mix 70 ml of tetrasamis plus 70 ml of F2 into this measuring cylinder. Then we put the sample into this conical flask and repeated the same method for walnut and F2. Make sure to replicate the sample. Then we pipette 3 ml using micropipette for cell counting in lab. Next, we cover the conical flask using aluminum foil and put it into aerator machine and look for its light intensity using light meter. So this is the method for cell counting. First, we take the medium for aerator machine and look for its light intensity and we record the reading. Next, bring the sample into fume hood, and before start, we must spray the fume using alcohol and wipe it. Remember to use the apparatus that have been sterilized at oven. Then start to sterile the pipette and make sure to put some alcohol at glove to make sure there is no contamination. As we can see here, the pipette has been sterilized. Next, we can see here we take off the aluminum foil and sterile it at the mouth of conical flask and start to take a single drop of this sample and then put it into the petri dish for the cell counting. Then put the alcohol at the conical flask and start to cover it with paraffin, followed with aluminum foil like here, and we wrap it with the paraffin. The step is repeated for all sample replicate of walnut and F2. After the step is done, take the photo of the sample to see the color changes. And then for cell counting, using hemocytometer, place a cover slip under the hemocytometer and put a droplet of the sample into the drain of hemocytometer. Okay. Then we observe it under the microscope. So for the harvesting method, first we put the filter paper on the filter pump. Then we measure 15 ml of the sample using measuring cylinder. As you can see here, it is 15 ml. Next, we put the sample into the filter pump and rinse it with distilled water to avoid the algae attached to it. Then we fold the filter paper and insert it into the aluminum foil. Then the aluminum foil is put into the oven for 1 hour and we put it into the desiccator. For record the weight, we need to take the aluminum from the desiccator using forceps. Then weight the aluminum that is free from filter paper and take the reading. Next, we put the filter paper that has been taken out for aluminum to take the reading. Lastly, record the reading until the reading becomes constant.
Okay, for the result, experiment algal batch culture, we can see this is the cell density calculations, which number of cells per mole equal to C times AT equal to AS times S times V, where the C is the total number of cells counted in the counting units, AT stands for area of produce in millimeter squared, AS also the area counting unit used in millimeter squared, and S number of counting unit counted, and the last is V volume of sample under the grid used in ml. Okay, so here we can see the result of F2 replicate 1, the cell density. The exponential phase we can see from this slide is at day 3 up to day 7, and this one is the Warner replicate 1, the cell density exponential phase is at day 2 up to day 10. Okay, so here we can see the overall result of every replicate Warner R1 and R2, F2 R1 and R2. This is the formula for growth rates where x2 and x1 equal to R cell density at 2 times, which is T2 and T1. The growth rate for Warner R1 is 0.219, the Warner R2 0.4486, while F2 R1 0.3831, and for F2 R2 0.3054. For the color change, you can see it's from green to brownish color, which means it's starting, the brownish color start to for their dead phase.
Next, for the division time, we use the formula as shown, which is division time equal to 0.6931 divided by growth rate. All the calculation for the division time of each of the medium Warner of replicate 1 and 2 and medium F2 replicate 1 and 2 is shown in the table. For the Warner R1, the division time is 2.646, while for the replicate 2 is 1.545. For the medium F2, the replicate 1, the division time is 1.809 and the replicate 2 is 2.269. Next, for the cell morphology, the picture shown the cell morphology of tetracellular species. We observe the cell morphology of the tetracellular species under 100 times magnification. The cell of tetracellular species is vary greatly in cell size and shape. The shape of the cell can be round and oval, and tetracellular species also have flagella on top of their body cell.
And I will continue with the biomass of alga. And here our reading for algae for 7 days. So where I get this reading is here. Yeah, as stated in the methodology, we need to weigh the filter pepper first, and then we filter the algae, and for the next day, we will weigh the mass of filter pepper and algae. So here, we weigh the algae for 7 days. Here, as stated here, and the weight we take for the replicate is we do it for 5 replicates, and here I calculated the average already, and I take the average reading, and the formula I use to calculate the dry weight is the mass filter pepper plus algae minus with the mass of filter pepper, so that we can get the mass of algae only. And for the biomass, okay, here I use the formula which is the mass of algae plus filter pepper minus with mass of filter pepper divide by volume, which is 15 ml. And here I already convert the unit of ml to liter, so that we can get the gram per liter, okay, for the unit. And next, this the graph I constructed here, okay, for F2R1, it shows that starting from day 6 to day 7, it start to constant, but the rest is still shows decreasing. But here it's a bit slanted, it's a bit increasing here, while the rest still decreasing. I think here it might be an error because of the person who in charge with the algae every day is different, and yeah, there might be error over there. And other than that, the error might be because of the analytical balance itself was placed besides other apparatus, and there might be a disturbance over there. And next is yeah, this our biomass. On day 7 for Walnut R1 is 5.464, Walnut R2 9.4453, and F2 R1 is 0.3400. For F2 R2 is 5.87x6. Okay, next is the reference that I use is one of these, and the reference state that alga biomass is determined by measuring either the dry wave or the ash-free dry wave. And here where I get the formula for dry wave, okay, from this journal itself. And next is the journal I used to, and yeah. Okay, the journal state that the low biomass in autotrophic group may be caused by carbon limitation because as no carbon dioxide was added into the medium. And yeah, previous study only focused on the influence ratio on the total lipid content and fatty acid composition. So we only do this analysis until the precumbers and rehabers so that we can get the biomass reading. And theoretically, adequate nutrition in the medium maintains microalgae in a good growth state, but the abundant carbon or nitrogen does not guarantee an increased growth rate. Yeah, but these journal, use the species of Tetracelmis juice, but it's quite same for our sample, which is our sample is Tetracelmis too, because we didn't add ID for our samples anti-species. So that's what this journal say.
As for the discussion for the color change of the algae, the color of the algae changed from the light green to dark green, then to yellowish. According to Long 2018, the color changing is due to the changes in the composition of the algae depending on the phase, which is lag phase, exponential phase, stationary phase, and death phase. According to Ali 2018, the algae lose color when it is stressed and the density of the algae is reduced. The light green indicate that the algae is in the lag phase and the dark green indicate that the algae is in the exponential phase. Once the medium turns to yellowish, the algae could be in the stationary phase or dead phase. So generally, the changes of the algae color will reflect the physiological state of the algae.
Okay, from the result just now, we can see that the growth rate of Tetracelmis species in F2 mediums actually have a better performance than in monomediums in the form of cell density and also the growth rate as well as the shorter division times. Well, when we're comparing the growth rate of algae between two different mediums, the first thing we have to look at is the nutrients. The nutrients concentrations in the cultural mediums manipulate the growth rate in microalgae cultures by increase or decrease of the compounds present in microalgae. According to Kim et al. In 2016, the Tetracelmis species grow better with nutrients like organic nitrogens, glycines, urea, and nitrate, where Chance have stated that the type of inorganic nitrogens, the algae are more prefer nitrogens in nitrate form compared to ammonium form. And therefore, the Tetracelmis grow better in F2 medium because the main components in F2 medium is sodium nitrate. The same components exist in the monomedium as well, but however, the ammoniums are found in the content of the composition of monomediums. Nitrogens in ammonium form cannot be utilized effectively by the algae, and that's why the algae culture in monomediums has lower or less preference growth rate compared to F2 mediums. And another factor that affecting the growth of algae is the light. The light will influence the growth rate through the process of photosynthesis, and there is a significant effect of the light on the cells number and division rate of algae. Temperature as well will influence the growth rate of algae. And come to other factors, the most important things is the methods. When we're having a lot of people carry out the same things, the problem is that we did not come to standardizations when we go to the counting methods. Different method might be used from different peoples. For example, the different stage applied to shake culture flask before counting the cells, and that's why the cells did not distribute even they cause a false count on cells number.
So, here the conclusion. Cell density is the one component to determine the microalgae growth rate. The higher density for Tetracelmis sp in medium F2 replicate 1 was at day 7, while the higher density of Tetracelmis sp in medium Werner replicate 1 was at day 10. Tetracelmis sp reached exponential phase earlier in F2 medium than in Werner medium, which indicate the growth rate of Tetracelmis sp was faster in F2 medium. The division time shows that Tetracelmis sp in F2 medium replicate 1 take less day to divide than in Werner medium replicate 1, while the color changes of Tetracelmis sp indicate the growth phase of the microalgae. Step precaution is needed to be more precise when handling the culture sample to avoid contamination and error occur. Avoid to put the different type of microalgae species in the same place, for example in the aerator machine. Lastly, use the correct method to insert the algae into the hemacytometer.